Hi guys, welcome to a new video of calculus. So today what we're going to learn is limits and derivative. In the previous video we learned how to use limits. We learned how to what meant to be what meant to find a continuous function and use limits in where x approaches infinity. So what we're going to learn is apply continuity. So we're gonna learn how continuous function um, is important for limits and derivative. So the first thing I'm gonna write here is our first video that we did, right? So let's put a reminder. Re- Remember when I told you guys what is a tangent line? My tangent line is basically a line that turns only one point, right? Let me just not quite of a line here. Not quite of an artist right here. So yeah, so this is basically my tangent line where I touch one point on my curve, and this is very important. Okay, this is my tangent line. So we learned to find our tangent line, we have to plug in our function x2 and minus fx1 has x2 minus x1. So this is our slope, and with the slope we can find our equation, right, for our tangent line. However, to find our slope, we had to plug in a lot of variables, right? Like for example, let's say what is my tangent line. For example, this is like, let's say 9 and this is 2. What we had to do is put all close value, all value of x that is close to 2 from the right, and all close value to 2 from the left, and we had to approximate different tangent line, right? So let's do an example as a reminder, right? Let's take a friendly function, a parabola, right? Let's draw a parabola. Let me just draw it well first. Okay, assume this is x2 plus 1, right? I just assume. Okay, this is my function. Right. So what we have to do is we have to first, we want to find a point, right? We have our point. Let's take 1 and 1. Now let's take let's be 1 and 2. Okay. So if x go to 1 plus 2, yeah. And what we had to do for our q was to take all q's that are close to 1. Okay, and what you have to do is take all those values inside of your function and get your slope, right? What we want to find is a tangent line. Let me just draw that real quick. So let's take another color. Let's take yellow. Okay, so let's say this is P at 1 and 2, and we want to find the slope at point P. So what I'm gonna do is take all values of x that are close to 1. So what I'm going to have is, yes, as I said, they will have 1. X that are coming from the right is going to be like 1.001, you get it, 1.001, you get 1.1, for example. And from the left, you have 0.999, then you get 0.99, and 0.9. Remember what we did in our first video, where we used to plug in all those values in my slope. Right, so this is my slope. Okay, and we had to plug in all those values that are close to x equal to 1. And it was long to calculate it, because we have a lot of slope. You have slope 1, slope 2, slope 3. Okay, so let's do this one. Okay, let's do this one, and I will show you a new trick that we can use instead of approximating it. Okay, so all right, let's see my slope 1. Okay, let's take 0.9. So what we're gonna have, x2, I'm gonna take 0.9 to the power of 2 minus wait, this is gonna be plus parentheses minus, then you have 2. Okay, then you take the denominator is 0.9 minus 1, right? So for the sake of time, I'm going to take only 2 here. Let's take, actually you're going to take 3 here for the sake of time. So let's take 0.999 plus 1 minus 2, 0.999 over 2 minus 1, and let's take 3. This time we're going to take, let's say, 1.01 to the power of 2 plus 1 minus 2, 1.001 to the power of 2 minus 1. Here's to the power of 2 here. But I get, no, this is just 1. I made a mistake. I'm sorry about that, guys. I went a bit too quick. Alright, so I guess I will edit it I will edit it and just mention it. Okay. Alright, so this is how we're gonna find our slope to approximate our tangent line. So take your calculator and calculate it. Right. So first one 0.9 to the power of 2 plus 1 minus 2. And 0.9 minus 1. And what we get first here is 1.9 here. Alright, so let's take 0.99. Here I'm getting 1.99. Now let's take 1.001. 1.001. Here is 2.001. So we can guess that my slope for my tangent line is approaching 2 from the right and from the left. Now, can you see where this is going? Right. Remember when we talk about limits? Basically, the definition is limits for f of x as my x approach a equals to L. And this is basically the function. I mean the equation, right? F of x here. And so the reason why I took 1.9 and 1.99 and 2.001. This is coming from the right and this is coming from the left. Alright, so it's basically proving if the limit exists or not, right? So this is my definition for my limit, and what I'm doing here by approximating my my slope, I'm basically using the limits, but in a very long way. So what I want to do is use limits instead of using this equation. We don't like this equation anymore. This equation stinks. We want to use limits, right? So let's do limits. Let's right. So I'll write this equation, okay? Because we want to find my slope, but with my limits, right? So this is my slope. X2 minus x1 and x2 minus x1. Okay. All right. So how are we going to do this? Well, first let's say a function. Let's draw a graph first, if I can draw. All right. So let's change color now. Let's take any type of function. Let's take this type of function. Yeah. All right. So let's draw a line. Let's change color first. All right. All right. So I want to find my tangent line at that point P. Okay. I'll define this will be my x equal to a, and this is equal to L, let's say. So what I'm basically doing with my limits is approaching x from the right and x from the left, right? This is basically my definition of my limits. And instead of for doing that function, what we're going to do with that, with my tangent line, right? We're going to have multiple tangent line that are approaching my tangent line right here. So this is my slope. Okay, this is my slope from my my equation of the line. All right, so you guys don't have to find the equation of the line, we have to find the slope. So we're basically approximating the slope. Okay. So what we're gonna do here is basically let me just erase this. Actually, yep, let's erase this one a little bit. We're gonna have to take 2 points from the right and from the left, and at the middle we're gonna have a, and at the right is going to be a plus h, the left is going to be a minus h. Okay, no matter what you take, when h is approaching a from the left and the right, you're making the tangent line more specific. Okay, you're basically making the tangent line more and more closer to the real tangent line. So this is what is happening. Okay, this is your value. Yeah, let's take it. Let's take this. We can either take this or this. Okay, but what we want is use this right here. Right. So let's write this. Okay, let's plug in our value in my slope equation. Right. So let's plug in it. This is gonna be a plus h minus a f of a, right? I hope you guys are not lost, because what I'm just taking is taking an x in front or before my a. Okay, my a is my point P, basically. This is my point P. and I want to approximate this. But we don't know our L, okay? Our L is basically going to be f of a right here. And my Q is going to be a plus h and f of a plus h. It could be a minus h instead. It doesn't matter. And we're going to do the same thing here. And it's going to be a minus h minus a. All right. No, it's going to be a plus h. Excuse me. A plus h minus a. All right. This is what I just done is create a variable. This can be b. This can be c. But instead of have relate, I have done what I'm done here. This is my h. This is my h. So basically, I have created a point on my x-axis that is h away in distance of h away from my second point, right? So here and here is going to be a distance of h, right? So, all right, an example of that. Let's take x equal to 2, and this is a 1, and I want to find my h. Let's take 0.9 here. So my h is going to be this is 1 point, not 0.1. What am I doing? This is going to be, let's take 1.01. So my h is going to be 1.01 minus 1 equal to 0.01. This is my h. Okay. So this is just taking an example, right? So this is basically the distance between my x2 minus x1 is equal to my h. Okay, so if my x2 minus x1 is equal to my h, x2 equal to x1 plus h, right? So this is this is my function. And instead of writing a, I'm going to replace it by x. Right here. X. Because we're going to take it out of x. So instead of, so it's going to be like, so I'm just going to take x right here. And you're going to see why. Okay. I'm replacing a by x. Because my x is my axis right here. Right. I want to choose my axis. And because we're taking a lot of x close to my a, this number a is close to a. Okay. So what I'm gonna do here, actually erase that. I want you to look at this, and guess where this is going. I'm gonna basically take my limit as x approach a, and what I'm going to replace is f of x plus h. It could be x minus h, doesn't make any difference because the limit should exist. If it doesn't exist, you need to prove it that the limit doesn't exist. My limit f of x plus h minus f of x divided by x plus h minus x, right? The reason why I press x by a is because x is approaching a and is never a. X is approaching a. Remind you what is the definition of a limit. But very important, is approaching a. Okay, all right. So this is why instead of writing a here, I have written x. Okay, because this is my variable. All right. So what we just basically need to do is take any function and do the limit, right? So this is our new equation to find our tangent line. So instead of taking x, values of x that are close to my point P, decimal very close to my point P, I can just do the limit, right? We have practiced that. Okay, you guys are pro now. So I'm just going to simplify this here. Just x minus x is equal to 0. So I'm just going to write h right here. Okay. And here I'm going to simplify it again. I made a mistake. Instead of writing x, I could write h. And erase my h here. I want my h equal to 0. Now follow me. What I want to do is to close in my x right here. My x is approaching a, right? Now let's take a equal to 1. Let's take x equal to 1.1. My x is going to be 0.1, right? But let's say if x is closer to a 1.01, what is going to be my h? 0.01. Let's take it again. X equal to 1.001. My h is going to be 0.001. Let's say x equal to 1.0000001. My h is equal to 0.00001. It's going to be 0.00001. Can you see where this is going? So I'm just going to write it here. So just going to write it here. As x approach a, h approach 0. And this is always the case. Alright. So instead of writing x, I'm gonna write 0. Okay. The reason why I'm not writing x, I'm gonna writing x is because h is most likely used everywhere. It's very common to use h, so I'm going to use h. Okay. So let's do this. Okay, this is what you guys are going to learn. Oops. So this is the equation. You guys don't have to remember that by heart, right? Because I hope the teacher gave you like a list of formula to bring to your test. But that doesn't matter, because whenever you guys are practicing, you're gonna automatically remember the equation, because the more you practice, the better you get, right? So practice a lot using limits for your tangent line. So I'm gonna write here my slope for my tangent line equation equal to limit as h approach to 0 for my function x plus h minus f of x divided by h. Okay, now let's take an example. I have done you guys are familiar with this my parabola, right? This time I'm gonna write let's say this. And let's take our point P was 1 and 2, right? Yeah, this is my point P. So let's define the slope at point P using my limits. Okay, so let's write our limit. H approach to 0. Now let's plug in x plus h in my function. So it's going to be x plus h to the power of 2 minus x, right? Minus x to the power of 2 plus 1. Forgot 2 plus 1 here. Yep. Actually, let's erase this and write this a bit more neatly. So this is plus 1 here. I'll give you parentheses here, just to be more organized. Minus x above 2 plus 1 divided by h. If you guys notice, if I plug in 0, I'm gonna get infinity. Yeah. So, and most likely you're gonna get an undefined form. So you don't want that. So what I'm gonna do is do what you usually do. You simplify. Something that you should not do is to use those. Is to use this. Coordinates to find your slope. Do not use these points to find your coordinates. Always use a limit. Okay? Do not make that mistake. Because it's very easy to make mistake like this. And what we can do is we can simplify our my numerator, right? For those who watch my video on how to evaluate limits, this is not supposed to be a problem for you, right? So 2h plus 1 minus x, my negative here is going to distribute in my bracket right here, minus 1. So 1 and 1 is gone, x and x is gone as well. So h is down here. So as my h approaches 0, I'm left with 2x plus x to the power of 2. But what we can do is to factorize my h, right? Let's factorize my h. Okay, but what I notice is that I can cancel out h here, and I'm left with 2x. Now, let's see what is my slope. My slope is 2, right? From my point P, my x value is 1. I put it here. I got 2. And what did we find out in the previous question we did? My slope was approaching 2. This is not something very surprising, right? We were supposed to get 2. Now let's do another question. This time I'm just gonna write it here. Oops. X to the above 2. Let's write limit x above 2 here for my here. This is let's write this again. All right, let's just write this again. Plus 1 here minus x to the power of 2 minus 1 divided by h. We get 2x. Then how about x to the power of, let's take my function instead of writing the limit directly. Take my function x3. Let's take this first. F of x3, x equal x to the power of 3 plus 1. Okay, so we want to find this, right? So let's do this limit. This time I won't be using any points. And if we're gonna see a pattern right here, this is my function x to the power of 2 plus 1. And what we're gonna do here is using x to the power of 3 plus 1. Okay. Then we're gonna use x to the power of, this is a here, this is b. Okay, so let's do x to the power of 3 plus 1. This is gonna be h plus x plus h to the power of 3 plus 1. This is gonna be minus, with parentheses, x to the power of 3 plus 1 divided by h. So let's expand my limit. This is going to be 0 here, by the way. Okay, so I can I'm going to use my Pascal triangle to expand my my x plus h to the power of 3 here. But you guys can just use it, can just distribute it normally. But I'm using the Pascal triangle to go faster. So here I'm going to get x to the power of 3 plus this is 3x to h plus 3x h to the power of 2 plus h to the power of 3 plus 1 here's 1, oops, plus 1 minus x to the power of 3. I'm going to expand my parentheses, minus 1. It shouldn't be much of a surprise. Okay. If you're having problem following me, write in the comment down below. Calibration, I don't understand what you just did. Can you explain it to me? And I will make sure to answer your question. Right. So now we just need to simplify it. My x to the power of 3 cancel out with my x to the power of 3. My 1 cancel out with my minus 1. And we are left with this equation. Okay, so we're left with this equation right here. And guys know where this is going. I'm gonna factorize my h. My h is gonna cancel out, and what I'm left is 3x to the power of 2. Alright. So what I basically did is factorize my h, cancel out my h from my numerator and my denominator, and just plug in 0 here to see if my limits is not an undefined form. It's not an undefined form because it is 3x to the power of 2. Now, question is, what is the slope? What is the tangent line? Yeah, what is the slope for my function f of x for my function x to the power of 3? I'm not gonna repeat what I just did because it's exactly the same step. You see here, my 1 just cancel out. Okay, you can put it 2, you can put it 3. My 1, 2, 3, 4, 5, 6, 7 is always gonna cancel out with each other. Right? So this is my so let's try to write it down here. If my x to the power of 2, if we take my if my x to the power of 2 is giving me 2x, my x to the power of 3 is going to be 3x to the power of 2. What is going to give you x? What do you think it's going to give you x? So let's do this. Let's take our limit h upwards 0, which is x plus h minus x divided by h. My x and my x is gonna cancel out. I got limit x approaching 0 h over h. Again, for those who are not following, this is basically for my function f of x equal to x, right? So here I have x equal to 1 here. All right, pause the video to see, to write this down. So what I just done is take the limit for my function f of x equal to x, right? So let's write it down here. F of, let's write it again, let's erase it and write it carefully, more tidy. So this is my f to the power of 2, x to the power of 3. So we have just done the limit for my function for my when h equals 0. If I take my limit as x as h equals 0 to find my slope, I'm getting 1. And if I'm taking my limit, if I took my limit h equals 0 for my x to the power of 2, we have just done it is 2x. And for x to the power of 3 is 3x to the power of 2. I feel like I have gone a bit too fast for my x. So I'm just gonna write it again. I'm gonna write it here. Minus x here. That's good. Because I just feel I went a bit too fast for this one. I'm sorry if I went too fast. So my x and here are gonna cancel out. And now it's h over h giving me 1. Alright. I'm gonna leave it here. So my function equal to x. Alright. So so what I can put then is I can just put my x 0 here, 1 here, and if I put my x to the power of 4, my pattern is saying me, so this is adding 1. So this is, you see, where's this going? This is increasing by 1. So if I take my limit as h equals 0 for my x to the power of 4, I'm gonna get 4x to the power of 3. See, it's basically increasing by 1. So this is increasing by 1, increasing by 1, increasing by 1. All right. So let's take a new page. And x, I limit as x approach 0 for my power x plus h to the power of n plus x to the power of n divided by h. What is giving me? So we found out that x, if I take my limit for that, I'm getting 1. I just put x to the power of 0 giving me 1, still doesn't change anything. X to the power of 2, it gives me 2x, give me x to the power of 1, x to the power of 3 giving me 3x to the power of 2. Right. You see, this one is always one step behind. So if I take x to the power of 4, I'm going to get 4x to the power of 3. And if I take x to the power of 5, I'm going to get 5x to the power of 4. Okay? So therefore, if I take x to the power of n, if I take my limit h plus 0 for that, I'm going to get my n is going to go in front. I'm going to get x to the power of n minus 1. And what do we call that? We call that derivative. Welcome to the notion of derivative. Well, the reason why I haven't revealed you what the derivative is because I wanted to connect everything by limits. So in this video, which is all about learning what is derivative. This is purely trying to show you guys um, the origin of derivations. Okay, and derivation is defined by this. Okay, or this, whatever you take, but most likely this. Okay, it's a bit stupid here. We're gonna be using this dy over dx or f of x, f prime x. Dy over dx is very important. This notion is very important. You guys to know this because it's basically going to be important for physics and later on calculus. The reason why is I'm just gonna write this. My dy is basically an change in y decimal, like instantaneous instantaneous change. Let me just write. Let me get the word for this. What I'm just gonna say is dy is basically it's difficult to see the word. It's basically a small instantaneous change in my dy, instantaneous change in my dx. Okay. What I mean by that is let's just take a graph for example. Okay, so this is our simple. So we want to find the slope. This is a linear function. This is differences in y, and differences is x. Okay, and you can basically make it closer. Okay, and the smaller my y gets, the smaller my x gets, the smaller my y is. This is something I will explore along the line in the end of calculus 1. But for now, you don't have to worry about this. For now, you just need to worry about how to calculate the derivations. So, if I had to give you something, so x of power of x, so the derivation of x to the power of n equal to n x power x to the power n minus 1. Alright, so this is my limit. This is my derivation for x to the power of n. How about my derivation for x? It's gonna give me y, right? So if I take x here, my 1 here, okay, my 1 is gonna go in front, and x is gonna be power 2, is gonna be to the power of 1 minus 1, give me 1 times 1, right? X to the power of 0 equal to 1. Right. And what you guys need to remember, another thing you need to remember, is the derivation of a constant is always 0. Remember when I did x to the power of 2 plus 1, and when I took the limit, the limit of that, no matter what I put for my 1, it's always going to cancel out, right? So it's going to give us 2x. So my 1, you don't have any derivation for that, it's just going to equal to 0. So far we have, what we have done is the limit, and the limit can be simplified as this. We're gonna look at more derivations, but for now This is what you guys need to know. Alright, so now that you guys are an expert in derivations, let's test how good you are. So let's take x to the power 5 plus 6 x to the power 7 minus 10 minus 10. I want to find the derivation of that. This is my f of x. So what is my dx dy? Now this is what is my dy dx? My dy dx. So let's take our derivation. Dy dx is gonna equal to, let's take my derivation of x to the power 5. My 5 is gonna go in front, and it's gonna be 5 minus 1, 4 x to the power 4 plus 6 times 7 x to the power of 6. 7 minus 1 is 6, right? I'll have to repeat that. I have to say that. Minus 10. My derivation of 10 is going to be 0. Okay. And what I'm left with here is it's basically 5x 4 plus 42 x power 6. This is how a general derivation looks like instead of doing the limits each and every time, because the limits can be quite long if I'm going to be honest. So far what we have done, something that you guys are going to be very hard for you guys, to be honest, and I totally get you, and you guys need practice. So the first, there are rules to derivations, right? And one condition for that is the limit must exist for to derive to derive it, right? Limit must exist in order to derive. Okay, very important. Now let's see. Can I just write you guys rules? All right. So let's just do it. So what I have done right here is let's just take my dy dx for my first function right here. Let's just take f of x. This is f of x prime of x. Let's just take f of x equal to h of x plus g of x. And if I want to find my derivations, is just going to be f prime h prime of x plus g prime of x. This is my derivation, right? Okay, so this is exactly what I've done. Okay, this is my h prime of x, this is my g prime of x. I could use dy dx, whatever. I'm using f. For now I'm going to be referring it as f prime of x. Okay, so this is simple derivation rules. Right, what I think that you guys should know is, for example, you have hx, my function h of x times g of x. If I take h prime of x, it's not going to equal h prime of x, h prime of x times g prime of x. This is completely wrong. So for example, if you have 2x times e to the power of x, you can't just derive x and derive e to the power of x. By the way, e to the power of x, I want to show you guys that. Okay, before we end the video. Okay, so this is a distribution law, just like we do with limits, right? It's like you guys are dealing with limits, but you just need remembering a bunch of equations. So it's basically distribution law. Distribution. for derivation. Okay. And now let's do f of x for my e to the power of x. Every time that you guys don't know how to derive, take your original limit. Limit h equals 0, f of x plus h minus f of x divided by h. Let's plug in our function. Minus e of x, e to the power of x plus h minus e to the power of e to the power of x divided by h. Okay. Just looking if I'm making a mistake. Okay, no. All right. So if I simplify this, I'm getting let's just this thing guys is gonna be e h minus e x here. H. And I'm gonna derive and I'm thinking about it. Yeah, I can simplify it. All right. Yeah. All right. Sorry for the delay. Something had come up. But well, so let's continue. So we have e times. We can just put e to the x in front of my limit because my x is not my variable I want to deal with. So just write this. And this limit, this is our special case that you guys need to remember. Unfortunately, these are things that you need to remember. Okay, every time you get this, it's always gonna be 1. Okay, it's a special case that you guys need to remember, and you have to trust me and trust mathematics. All right, so my derivation. Okay, this is my derivation of e to the power of x is e to the power of x. All right, so this is I'm actually gonna take a bunch of put it here. So rules. Okay. I'm just gonna write the rules again. And if you take the derivation of that, derive each function in your function. And this is for now. You need to remember this. We'll go throughout multiple rules, but for starters, you need to know this. Then what we're gonna see is so my derivation of how do I show it? Yeah, let's just write it like this. Divide the x for my function f x to the power of n is going to equal to n x minus n x. Excuse me, I don't know how to spell it. X times n times x to the power of n minus 1. This is a derivation for x to the power of n. What about the derivation of a constant c? The constant c is going to give you 0. Derivation of, we just did the proof. It's a very special case for that. is gonna give us e to the power of x. So the only derivation, the only derivation of a function that is equal, that doesn't change, is e to the power of x. So this doesn't change, right? So throughout the video, we have gone to derive all of those three. We have three rules you guys need to remember. Three equation more likely. So welcome to calculus. I hope you guys enjoy this video, and this is just the beginning of it. We're gonna use derivation so much. It's gonna be so relevant from now on. And I'm gonna say this: limit is the ABCD of calculus. All right. So I hope you guys understand what is limit, because if you go further into calculus 2 and 3, limits are still going to be used. We're not going to just dispose of limits. We're still going to be using limits. Okay? But to find the tangent line of using derivation from another. Okay? Derivation is what we're going to find. So this is for the tangent line. You can cast tangent line, instantaneous slope. Whatever you guys choose to call it. You can even call it rate of change. Because it is your slope. I hope you guys enjoyed this video. It's definitely a lot to take in, but watch it, take your time. You can even skip some part. Yeah, obviously you're gonna miss up something, but if you guys want to speed things up, you can do it. Take this at your own pace. And if you guys have any questions, ask me. Need anything, ask me. Again, I'm gonna make another video on derivation. This time it's gonna be on question rules and product rules. It's also contain chain rules. There's a lot of rules in derivations, and limits is gonna be our base always. All right. Goodbye. Have a good day.